Good afternoon, class. We are looking at Chapter 5, Integrals, Section 5.1 to 5.3, the Fundamental Theorem of Calculus. Here's the second part. We want to integrate 5x squared minus 4x plus 2 dx from 0 to 2. So one of the FTCs says the integral of a to b f of x dx, which is called a definite integral, which is a number, is capital F of b minus f of a. We are going to find the antiderivative. For this one is 5, there's x cubed. This one is minus 4 halves or minus 2x squared. This is plus 2x, and we're going to evaluate it from 0 to 2. I want to make sure we understand what happens in this case. Minus 4 divided by negative 1 plus 1 x to the power of negative x to the power of 1 plus 1. So we plug in 2 and we plug in 0. 0 will result in 0 because everything involves x or powers of x. This is 8. Or the thirds. This is 4 minus 8 plus 4. These two add up to minus 4, which is minus 12 thirds. Combination of these two, 28 thirds is the final answer. To integrate this one, we make up this fraction, which gives us 4v cubed, and the second one minus 3. The integral of 4v cubed is v to the power of 4, because 4 divided by 4v to the power of 3 plus 1, minus 3v, and evaluate it from 1 to 2. We're going to plug in 2. We get 2 to the power of 4 minus 3 times 2, and then minus, plug in 1. We get 16 minus 6, which is 10. We get 1 minus 3, which is negative 2. And now it makes it positive 2. The result is 12. Now, we did this one previously. If you go back to your notes, you make up 3 fractions. This is one of them, which is 1. This is another one, which is negative 7 over x. And finally, 2 over x squared. We rewrite this as negative 7 times 1 over x, because we want to notice that we can easily answer it. And we're going to write this in power format, 2x to the power of minus 2. So 1 gives you x, minus 7 times 1 over x gives you minus 7 ln of absolute value of x. And this one, again, we have done this before, gives you 2 divided, this is a power rule, divided by negative 2 plus 1, x to the power of negative 2 plus 1, which gives you minus 2 x to the power of negative 1, or minus 2 over x. We're going to evaluate from 1 to 3. So we're going to plug in 3 and we're going to plug in 1. Now the first bracket, we're not going to touch it. We're going to keep it intact. Notice ln1 is 0. So what you're dealing with is 1 minus 2, which makes it negative 1. The negative in front of it makes it positive 1. Now we have 3 numbers. 3 is 9 thirds, and 1 is 3 thirds. So if I add 9 thirds, 12 thirds minus 2 thirds, 10 thirds minus 7 ln 3. And this is an exact answer, everybody. And we want to keep it as exact. Should always keep it as exact in calculus. Again, this was done. Pay attention that the independent variable, because we have dt, the independent variable is t, so 1 gives you t. The derivative of cosine is negative sign, but the integral of cosine is positive sign. So t plus sine t evaluated from the lower limit 0 to upper limit pi over 2. We are going to plug in the upper limit first, minus plug in the lower limit second. We should know sine of 0 is 0, and we should know sine of pi over 2 is 1, and pi over 2 plus 1 again. This is an exact answer, everybody. I want to keep it as exact. The integral of 5x squared of x plus 3 squared of x dx, evaluating from 1 to 4. We're going to change this to x to the power of 1/2. And we add it to this one, 1/2 and 1 becomes 3/2. In other words, change this to x to the power of 1/2 first, and then this exponent is 1 and 1/2, they add up. So 5x to the power of 3/2 plus 3x to the power of 1/2. Why are we writing it in this format? So we can use the power rule in each case. So this one, 5 divided by 3/2 plus 1, x to the power of 3/2 plus 1. This one, 3 divided by 1/2 plus 1, x to the power of 1/2 plus 1. We don't need a constant because we are evaluating from the lower limit 1 to the upper limit 4. And we notice three halves and 1 is 5/2. This is 2, 1/2 and 1, 3/2. This also is 2. Now let's plug in the upper limit 4 minus plug in the lower limit 1. We have to simplify this. Of course, this is easy. This is 1, this is 1. But what happens to 4 to the power of 5/2 means square root of 4 to the power of 5. Square root of 4 is 2. 2 to the power of 5 is 32. You have the 2 in front, and this becomes 64. 4 to the power of 3/2 is square root of 4 cubed. 2 cubed, 8 times 2 is plus 16. The brackets, 2 plus 2 is 4. We have minus 4. 64 and minus 4 is 60, and 16. They add up to 76. So as you can see, this is the only calculus step, everybody. And everything else is basic math, elementary algebra, you call it, whatever you want to call it, and it's very simple. Example number 7, water flows from the bottom of a storage tank at a rate of R of t equals 200 minus 40 liters per minute. Find the amount of water that flows from the tank during the first 10 minutes. This is the rate or the derivative function. Lowercase r of t is the derivative, so we can use capital R of t to represent the actual function. So if capital R of t represents the amount of water that flows from the tank at time t, then the rate of flow is given by its derivative, capital R prime of t, or lowercase r of t equals 200 minus 40. Therefore, the amount of water that flows from the tank during the first 10 minutes, it follows the theorem, which is also called accumulated change or the net change theorem, the integral of a to b f of x dx, lowercase f of x, where capital F is the antiderivative of that, f of b minus f of a, is also known as accumulated change or net change. Therefore, the integral of this for the first 10 minutes would be from a to b, namely 0 to 10. This is 200t, this is minus 2t squared. We plug in the upper limit, minus plug in the lower limit. We get 2000 here, minus 200. And the answer is 1800 liters, because when we go back to the rate or the derivative, the units were liters per minute. So this must be liters. There is a second method, and that is, instead of evaluating it from 0 to 10, you find the function capital R of t. Since there is nothing mentioned here, the initial value at time 0, there is no water flow, so it's 0. You can find the constant, and then at any minute, 10 minutes later, 20 minutes later, you plug in those numbers. That's a second method to use that. And so for this question, I'm going to do both methods, so you'll be exposed to both of them. Many fish grow in a way that is described by the von Bertalanffy growth equation. For a fish that starts life with a length of 1 centimeter and has a maximum length of 30 centimeters, this equation predicts that the growth rate is 29 e to the power minus x centimeters per year, where x is the age of the fish. How long will the fish be after 4 years? Well, same as before, we are given the growth rate, the derivative function. So if L of x represents the length of fish at any age x, then the growth rate is the derivative of that, L prime of x, or dl dx equals 29 e to the power minus x. And this is the initial value, L of 0 equals 1, because they say so. Starts life with a length of 1 centimeter. The fish starts life with a length of 1 centimeter. So if we want to go with the accumulated change theorem, we take the integral of this. So the amount of increase in length for the first 4 years is this from a to b, from 0 to 4. And here's your function. And to integrate this, we divide by -1. We end up with negative 29 e to the power minus x. From 0 to 4, so plug in 4 minus plug in 0. It's easier to keep the negative 29 out as a common factor. Although e to the power of 0 is 1, everybody, you have to use a calculator anyways for the rest of it. It ends up being 28.4688, and this was the initial value. The initial size is for the fish 1 centimeter. This is the amount of increase. So L of 4 is the sum of the two numbers, which is 29.4688. They said use 1 decimal. So when you go with the first decimal, next to it is 6, you move it up to 5. Remember, when the number is 5 or larger, you change that. Here's the second method, everybody. we are going to integrate this without paying any attention to the limits. We already have the answer plus a constant, and we have an initial value here. This one means L of 0 equals 1. Because we have an initial value, because we have a pair, we can find the missing c. So if we replace the x with 0, the y or L of x becomes 1. E to the power minus 0 is 1. So we have negative 29 plus some number is 1. That some number must be number 30. Now, what is the advantage of that? If we want the length of 4 years, we put x equals 4. What is the fish after 5 years? How long is the fish after 5 years? Plug in 5. How long is the fish after 10 years? Plug in 10. That is the advantage of that. It makes it easier that way if you have several parts to do.